start with a new project here. I'm going to create a folder, call it icons here, and we'll go in and drag in all our images into it, and then go back up and I'll drag in the grid image here. Then I'm going to create a node and I'll call it item DB, and we'll add a script to it, and that will be an item database script here I wrote. So we're going to get the path to the icons as a constant, and then I'm going to define a dictionary of every single item we'll have. So this is the dictionary. The name of the item is its ID, and then that points to a value of a dictionary that has the icon path. So just concatenate the path of the icon folder with its image name, and then the slot that it goes in. And then so some will have no slot, and then I have an error image which I'll use here. I define a get item method that just checks when we pass in the item ID of the item we want, checks if that exists, and if it does, we return it, otherwise it returns the error item. So it's just a debug check thing you can use. Something else you might want to do is check if the icon path is valid, and then if it isn't, you return another error image or error item as a check for that. So I'm going to save this and then go into project settings, auto load, and we'll add item DB, click add, and also input map. I want to add inventory grab here and add mouse button, left button for that. Now we need to add in a texture rectangle. Here you can just search, and then I'm going to call this item base here, and then I want to set the rect size to be 0 and 0, and we'll just save that. And then finally we need to add in a control. I'll call this inventory, and as a child we'll add in a panel, and then I'll duplicate that, and then I also want a texture rect as a child of it. And for this I'm going to put in the grid PNG image there. The inventory anchor, I want it to be at the center, so 0.5, and then margin zeroed out. And then this is going to be the inventory base, so like the background part. I'm just going to drag this out here, and if you don't have these dots, you just hit Q to make them visible. This will be the equipment slots, and then this will be the grid backpack, which I'll move right there. Equipment slots, and just middle mouse button drag to move around here. So I'm going to move this here. You hit W to go into move mode, and I'm going to drag it down like this, and I want to go to visibility down here, self-modulate. I'm going to set it a darker color, and then I'll save that color. Go over to grid backpack and do the same thing. That looks better. And then as a child of this, I want to add another panel here, something like that. Duplicate with Control D, and W, hold Shift to move it down exactly on the axis, and you can do see that, duplicate, move that down, and then I want one more for here. That looks good. So I'll name this head. So these will be the slot names. Legs, which will be used in the script main hand. So let's start with the inventory script itself. There's a lot on this, so let's start with all the values here. We're going to preload the item base as a constant since it never changes. Get references to all these three things here. This will be a reference to when we click and drag an item. This will be the item we're dragging. This will be the offset between the item's position and our mouse cursor, so that way if you grab like the bottom right of the item and drag it around, it won't snap, so the top left corner is right at the mouse position. It'll keep its relative position. This will be the container we picked it up from and its position when we picked it up. So let's go in and do our input calculation. So we get our cursor position, and if we just pressed it down, we'll call a grab method, and if we just released it, we'll call a release method. If we are holding something, we'll set its position to be the cursor position plus the offset. So for the grab method, the first thing I need to do is get which of these containers is under the cursor. So I'll write a method for that. Pretty simple. It just loops through. So I get an array. This is the order it'll check them in. I want the inventory base to be last. Loop through each of these and get its rectangle shape. So this, the rect would just be that. And check if it has the cursor point. If it does, return that. And if none of them do, we return null. So we come back into grab here. And if we successfully grabbed a container, and if that container has a grab item method, then we are going to call grab item and set the item held to that. And that'll return either the item or null if there is nothing to grab there. And then, so if the item held is not null, we record the last container, last position, calculate the item offset by subtracting the cursor position from its position. And then we want to set the child index of the item that we just grabbed to be at the very last position, so that'll be rendered on top of everything else. We just set it last index there. Now we want a release method. So if we're not holding anything, then just ignore return. Otherwise, we'll get whatever container is under us, and we're going to try to call insert method on that. So first off, if there's no container under the cursor, we want to just drop the item. Otherwise, that means like if we're dragging an item when we released it over here, then we drop the item. Otherwise, if it has an insert item method defined, then we'll attempt to insert it. An insert item will return true or false based on if it's successful insertion. And so if it's successful, then set the item held to null. Otherwise, you're going to return the item to its last slot. And if the container does not have an insert item method, then also return to last. So like if you let go right there, then it would return to wherever you picked it up from. So let's define return item and drop item here. Drop item is just going to delete it and set item held to null. In an actual game, you would want to instance the real world object for it first, like a 3D model or something. And return item just sets it to be at its last position, and it tries to insert it into the container as last in, and that'll always succeed because that spot is empty because you just picked it up from there, and it can be put into that spot because you previously had it there, and then just set item held to null. I'll save that. And then on inventory slots, equipment slots, clear this out. Let's go here. And we're going to start with, so get all the slots, which are just the children of this. And then all our items will be stored in a dictionary, and we're going to loop through in the ready function. So for each slot, we're going to set the index of items to be the slot name, and for that index set it to be null. So that way we'll have an index that has, or a dictionary that has 4 values that are null, and their index ID would be these slot names here. Now if you try to insert an item here, we're gonna see which slot. We want to get the position, the center of the position. Since this gives the top left position of an item, we want to get the center, so we get the rectangle size of the item divided by 2 and add it to this, and that'll give the center. And we want to see if there's a slot under that item position. So for that, I use a few utility functions here. So first off, there's get thing under position, where I pass in an array and a position, and it checks each one of those and sees if it's not null, then we want to just check if that rectangle contains this position, and if it does, we return that. Otherwise, if none of them do, we return null. And then for get item position, under position, I call this, and I just pass in the item's values. And that's why I have to have a null check, because sometimes those might be null. And then get slot under position, I just pass in all the slots to this method. So we try to get the slot under the item position. If it's null, then return false. We can't insert an item there because there's no slot to insert it into. Otherwise, we're going to get the slot the item needs to go into. So we can reference the item DB by just typing item DB dot whatever, and we call the get item method, and we're going to pass in. So the item, when we create the item, which I haven't set up yet, we're going to set its meta, the ID meta, to be whatever its item ID is. So we just retrieve that ID, and then we call get item with that, and we're going to get the slot value from the item information returned by item DB. And then, so we have the slot information, see if that matches the slot we're trying to put it in, and if it doesn't, then return false. See if that slot in the items dictionary is already taken, so it's not null. If it is, return false. Otherwise, we set that slot to be this item, and then we want to set the item position to be at the centered on that slot. So we get, this is the top, we want to set the top, that's the only thing we can do is set the top left position since it's a control node. So we want to set the top left position to be the slot's top left position plus half the midway point of the slot. So this gives the midway point of the slot minus half of the item. So like, this is the top left of the slot, top left of this, and then half the item would give us like right there. And then return true because it was successfully set up. And then for grab item, it's pretty easy. All you do is get the item under position. If it's null, return null. Otherwise, set this slot, get the slot the same way we did up here, and set that slot to be null in items. And that's good to go. Didn't miss anything there. And then finally, the grid backpack, the most complicated part. Create the script for this. So we start off, we have our items list. This is going to be an array here. And then a grid, this will be a 2D array of Boolean values, and I just found it easier to use a dict for that as opposed to setting up an array for it. Cell size, every cell is 32 by 32 pixels, and these are just initialized to 0 right now, but this will be how many cells wide and tall the grid backpack thing is. So for calculating that, we want to get the grid size, which will be calculated in a method I'll define here. So get grid size, results will be a dict. I don't want to use vector 2's because they have floating point values and I want integers. So I use a dict and I get the item's rectangle size. Then I divide that size by the cell size, convert that to an integer, and then I clamp it so it can't be lower than 1, and then I have an arbitrarily large value because you can't do clamp with just minimum. And then set the results.x. So that's a cool thing you can do with dict. You don't have to actually set the index by doing the square brackets. You can just do dot ID name and set something. So I do dot x and dot y, return the results. So I'll use that here to set the grid width and height, and then I'll also loop through the range there and set each x value index on the grid to be an empty dict, and then xy to be false. So initialize a 2D array of all false values. And now we'll set up the insert method. So what we need here, we'll start with this. So we get the item position. This is the top left position, and then we're going to add half a cell size to it. So like if I have a position I pass in right here, then, and it's a 3 by 3, I get the top left position and then I move it in by half a cell size, so I'd be getting that position right there. And I'll show you why later, why that seems to be the most comfortable place to insert at, I think. And so I want to convert this position to a grid coordinate. So I do that with, I get the local position in, so we pass in a global position and I want to get it local to this here. So I just, if I have this position, then I take it and I subtract it by this global position, and that gives me a localized position, and then I can convert that to a grid coordinate by just dividing it by the cell size and converting that to an int, and then I do the same thing with a 2-element dictionary here. So I get the grid coordinate and then I get the grid size of the item. And then I need to check if there's actually space at the spot I'm trying to insert it at. So I'm going to create an isGridSpaceAvailable method. And what this does is we pass in the coordinate we want to insert at and the width and height of the item. And then we just check, we do a bounds check to make sure it's not going over the sides of the image, of the grid backpack. And then we just loop through from the coordinate to the end, the edge of the space, and just see if all of those spots, all the cells are false, meaning there's nothing in them. And if they all are, we return true, there's space available. Otherwise, if one of them is set to true, that means there's an item in the spot in one of the cells where we're trying to put the item, so we return false, so there's no space available. Then we want to be able to set that space actually, so like same thing pretty much, except we pass in a state also, and we just set all those grid spots to be whatever that state is, true or false. So to finish out this insert method, we set the grid space for the item position and size that we just got. Set that, if there's space, then we set all those spots to be true, so there is an item there, and we set the item's position to be the top left position of the grid cell, which is the grid position times grid size plus the top left position of the cell, or of the grid backpack. So we get this position plus if we have 0, 1, 2, 0, 1, 2, let's say we have 2, 2 as our grid coordinate, we would get 0, 1, 2, 0, 1, 2 times cell size, so 64, 64 plus whatever this is, and then that would give us this point right here, and that would set the item's top left point to be that, so it would slot in right there. And then we append that item onto our items list up here, and we return true, successful insert. If there wasn't space available, we return false. And then we need a grab method. So get the item under our current position, so we need one of these again. Utility method. I'll do that right here. So we just check every item we have, check if one of them contains our cursor position. If it does, then return that item. Return that item if we got an item. If we didn't, return null, so we didn't grab anything. Otherwise, we want to get the position of the item, the top left, plus half a cell size, convert that to a grid coordinate, get the grid size of the item again, pretty much the same stuff, and then we just clear out all the space that it contained, and then we remove that item from the array. So remove takes an integer index, the location of the item, so I just call find, pass in the item, and it'll find that item, and then delete it. This gets the index of it, then we pass it into remove to delete it from our array, and then we return the item itself with grab. And then the last thing we need here is an insert item at last position, a last available, or the first available spot, I mean. So we want to go, if we pick up an item, we want to try to put it in right there. If that spot's taken, we'll try there, 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 there. So left to right, top to bottom. So we start, that's why we start with Y, and then the inner loop will be X. So we'll check each X spot first, and then we go down one Y and check each Y spot, or each X spot on that row. So all we do is just, if that spot's available, set the item's top left position to be the same as the top left position of that cell, and then attempt to insert there. And if it's successful, return true. Otherwise, if no spot is available, then we return false. So if we go back to our inventory here, I want to define a pickup item method, which will, we instance our item base, then we set its ID, its meta ID to be the item ID, then we set its texture to load, we load the icon from the icon path from the item DB, set the texture to that, and then we add the item as a child to the inventory. Then we call insert item at first available spot with this. And if that's not successful, there's no space, then we just delete the item and return false. If it was successful, we return true. So I don't actually use these, but in an actual game, you would want to check, like, when you pick up an item, you want to see if this is successful, and if it isn't, then you play a message like not enough space, and if it is, then you delete the item from the real world, or the game world. And then finally, I think this is it. I'm just going to insert a bunch of items, just pick up a bunch. So items, and then a random value to test the error item. Let's see if this works. I might have missed something. Hit F5 to run. Let's select the inventory scene, and it's working. Just click and drag. There's the error item. I can put this, that's the chest slot there. If I try to put it on a different slot, it doesn't work. If I drag it to there, it returns to where it was. If I drag it out here, it deletes it. If I try to put something, see, it doesn't go in the wrong slot. I can put sword there, armor there, delete that, turns to the last spot. Can't place it on top of something else, and you'll notice that whatever I pick up is on top of the other one, so the index is set properly. And you'll notice, remember how it's easier to see with the error item, how I get half the, I insert at half the position there, so it's like, if I wasn't getting, adding half a cell size to the top left position, then if I went like this, it would insert it up here, but by doing this, it gives you more of a comfortable position to insert at. It just feels better. See, get a little leeway. So that's all.